Welcome back. We are about to start Unit 8, which is on stellar evolution. Now here, the term evolution, I do not mean biology. By the word evolution, I mean slow change, because as we'll find out, stars are not constant, they change over time. In this mini lecture, we are going to learn about nebulae and the interstellar medium. So in this unit on stellar evolution, as I said, here we're going to talk about the interstellar medium. In our second mini lecture, we're going to talk about star formation. Then in mini lectures 3 and 4, we're going to talk about end-of-life issues for stars, in particular how they age and leading up to their deaths. So this is the life cycle of humans. When we are formed, we're an embryo in our mother's womb. The outside world has trouble seeing us unless we have some special instruments to be able to peer inside. And when we're first born, we're still growing, we're still learning. We can have some tumultuous times in our teens, but finally we grow up and we become a mature human being. And this sort of middle age of our life lasts for most of our lifetime, from our late teens into our 50s or 60s or even later, before we show any marked signs of aging. Yeah, we do get a few wrinkles and gray hairs along the way, but then once we reach our senior citizen ages, we start to age much more quickly. We start to show signs of it, and we grow old and we die. Unless we are well embalmed, our body decays and the atoms go back into the earth where they can be recycled into future generations. Stars have a very similar life cycle. They are born in clouds of dust, and in these stellar wombs, the protostars, the infant stars, are hidden from our view until they finally reach something that we call the birth line. And at this point, the star emerges from its dusty cocoon, and we can see it, but the stars are still growing, they're still feeding on gas from the surrounding medium, until finally they reach a mature stage, a middle age, and that's where our sun is now. Perhaps a planets around it, and lasting millions or billions or even trillions of years, depending on the type of star. Eventually the sun will reach its senior citizen age, if you want to call it that. It will grow into a red giant star, and very quickly it's heading toward the end of its life. At the end of the sun's life, it will cast off most of its outer layers into another type of nebula, and those outer layers will then be recycled into the interstellar medium and incorporated into new generations of stars. So back when we talked about the sun, we talked about how the structure of the sun is determined in large part by the balance between gravity, pulling the sun's outer layers down, and pressure of the inner layers pushing up to keep the sun from collapsing. And what we will find is that during the birth, life, and even death of stars, it's dominated by this interaction between gravity trying to shrink the star smaller and pressure trying to push the star back out again. And which of these dominates at each stage of the star's life dominates what the star looks like. So the beginning of our tale begins with something called the interstellar medium. Inter means between, stellar means star, and a medium is just material. So this is material, mostly gas and dust, that is located between stars. Now you may say, wait, space is empty. Well, it's mostly empty. It is a very good vacuum, but it's not completely empty. Here's a picture of the area around the star Antares. Antares is in the constellation Scorpius, and you see that there are several different types of clouds and nebulae around. We're going to talk about these in the future. Now, for the most part, the interstellar medium is not visible in optical light, because the gas is transparent and the dust is dark, so we don't see much. But a dramatic observation of how even what looks like empty space is filled with material can be shown from an object called V838 Monoceros. Terrible name for a really interesting event. So here you see there's a small cluster of stars in this part of the sky. This is a picture taken back in the 1950s, and that star that's right at the center of this picture. In 2002, it suddenly got very bright and then faded away very quickly. The cause of that flash is still unknown, and this acted like a flash bulb. So this flash lit up the material around it, and when the Hubble Space Telescope looked in 2003 at this source of light, here is what it saw. These beautiful swirling brown areas are dust in space, very similar to the dust that's on the hood of your car. So what you are seeing here is not material thrown off by the star, but just the star's surroundings that are being lit up as the light travels outward from the star and then bounces toward us. I'm now going to show you a series of images pieced together, so it looks sort of like a movie, of this flash of light, which we call a light echo. The light went out from the star, bounced, and now is coming towards the Earth. Here is one of the first pictures the Hubble telescope took, and now I will start the movie and it will dissolve into later and later pictures, and this sequence takes place over a period of 4 years. And as a reminder, what you've seen here is not material moving away from the star. It's the light from the star lighting up stuff that's further away. So all of these delicate swirls of material are dust clouds out in space further and further from the star. At this point, we're looking almost out to 4 light years away, because it's been 4 years since the star went off when this picture was taken. Space, the vacuum of space, the space between stars, is full of gas and dust, and most of the time we cannot see that material. When we can see the material, such as in the previous page or under other conditions, we call that material a nebula. The plural for nebula is nebulae, and a nebula is just a cloud of gas and dust in space. Nebula is Latin for cloud. So there are many, many different types and causes of nebulae. We're only going to talk about a few of them, and the ones that I want you to learn are the following, and we'll go through them in the next few slides. First, there's a type of nebula called a reflection nebula. Second, there are several types of nebulae called emission nebulae, and among those are star-forming nebulae, obviously where stars form, planetary nebulae, and supernova remnants. And the final type I want you to know and be able to recognize is dark nebulae. From its name, you can probably guess that a reflection nebula is just dust that has been made visible by light from nearby stars. What we saw in the movie of V838 MON is a temporary reflection nebula because light from the outburst was bouncing off the dust and coming back towards the Earth. Here on the right is a picture of the Pleiades star cluster, and in pictures taken with large telescopes you can see around the brightest stars these swirls of bluish cloudy material. This is the reflection nebula. These swirls are dust in space that happens to be near these stars. These stars are very bright blue stars, and so the light from these stars bounces off the surrounding dust and comes toward us, and then we can see the dust. On the left is a close-up picture of part of this dust being lit by the star that's on the left of the image, and you can see it's very tenuous, very fine strands, and we wouldn't be able to see this dust if it were not for the light of these bright stars. Because it takes a lot of light to bounce off the dust, we need a lot of light, a very bright source of light, to illuminate a reflection nebula. And because most of the brightest stars in the galaxy are blue, then most of the reflection nebulae that we see are blue. There are exceptions. Near a couple of red supergiant stars, they're bright enough to light up some dust, so we see kind of a reddish brown color. You saw V838 Monoceros, that movie we saw earlier. That was a brownish color because the light that came off the star was a reddish, orangish color. So a good way to tell a reflection nebula is by its color. if it looks a bright blue color, and if there are bright stars nearby, it's almost certainly a reflection nebula. Because the light that we are seeing is reflecting off the dust particles, if we were to take a spectrum of the light from this nebula, the spectrum we see would be an absorption line spectrum that looks like the spectral type of the star that's lighting up the nebula. Our next type of nebula is an emission nebula. Emission nebulae are clouds of glowing gas, and this gas has been energized usually by hot stars, sometimes by other events like a stellar explosion. And because this is energized gas, if we look at it with a spectrum, we would see an emission line spectrum. And since the most common gas in the universe is hydrogen, hydrogen's emission lines in the optical are primarily red with a little bit of aqua and purple. So emission nebulae often, though not always, they often look kind of pinkish in color. One type of emission nebula to know is a star-forming nebula. Often these are pink in color because they are made out of mostly hydrogen. Star-forming nebulae are where new stars are being born. The Orion Nebula is one. Here's another one called the Eagle Nebula. If you look close to the center of the nebula, you see a bunch of bright stars there. Those are the stars that have just formed, and it's the energy from these stars that is energizing the gas and causing it to glow. These are young stars, they're very hot young stars, and very blue stars. Another type of emission nebula is called a planetary nebula. Now these have nothing to do with planets around stars. They get these names from back in the 1700s when telescopes were first discovering planetary nebulae. They look kind of like planets, especially in a bad telescope. They're kind of faint, round smudges. Nowadays, with better telescopes, we can see that they are not perfectly round smudges. They are in fact delicate clouds of gas. Here's a famous picture taken by the Hubble telescope of a nebula called the Cat's Eye Nebula. Planetary nebulae are the outer layers of sun-like stars that are in the process of dying. As a sun-like star dies, it ejects its gas back out into space, and when it does that, it uncovers the nuclear reactor at the center of the sun. That's the bright dot at the center of this nebula. That is hot enough and energetic enough to energize the gas and make it glow. So planetary nebulae, they often are either almost perfectly round or ring-like in shape. Sometimes they look hourglass in shape. If you see a nebula that's almost perfectly round with a few delicate things, and there's a star at the center, like here, then it's almost certainly a planetary nebula. The final type of emission nebula I would like you to know is a supernova remnant. This is a picture of the supernova remnant, the Crab Nebula, or Messier 1. We talked about it in the winter skies. This is a star that exploded at the end of its life. And if you look carefully here at this Hubble picture, you see no bright star at the middle. The star blew itself apart. There is a remnant, we'll talk about those in the next unit, a neutron star, but it's so faint in optical light we can't see it in this picture. And what you are seeing here are the outer layers of the star that were blasted off into space. And so supernova remnants, they're often kind of round because they came from a star at the middle and everything's moving outward from that point. It looks like something exploded. The final type of nebulae we'll talk about are dark nebulae. Dark nebulae are clouds of gas and dust that in optical light block the background light. Here's a picture of the Milky Way pieced together from several different individual images, and what looks like a lack of stars going in the stripe across the middle is really dust in our galaxy that's blocking the light of background stars. The dust in space is very good at blocking optical light, and so we see these clouds as a lack of light coming from certain areas where you would expect there to be light. Here's an example of another dark nebula. Again, you see stars all around the edges, and in the middle you see nothing. But dark nebulae, they're blocking mostly optical light. infrared light and radio light can pass right on through. So on the right we have an infrared picture of this dark nebula on the left, and in the infrared you can see stars through the nebula. You can still see that the cloud's there and absorbing a little bit of light. The reason that dark nebulae are dark is because they consist mostly of gas, which is transparent, and dust. The dust in space is opaque. It's very similar in size and even in structure to an extent to the dust that we find on the Earth. They're made by different processes, but they look the same. On the left here is a microscopic image of a dust grain collected by one of our spacecraft called Stardust. And you can see it looks just kind of like an irregular shape of fluff. In deep space, where it's very cold, this little fluffy dust grain will be surrounded by an ice coating. And these ices include water ice, ammonia ice, methane ice, other things that evaporate when they get close to the sun, but far away from a star they can be cold enough that they turn into ice. And so I like to think of a interstellar dust grain, and there's a cartoon of one here on the right. It's sort of like a backwards ice cream bar. It's crunchy in the middle with a creamy coating on the outside. Often dark nebulae and emission nebulae, especially star-forming nebulae, will be found together. Here's a picture of the center of the Eagle Nebula. That was the pink star-forming nebula we saw several slides ago. This is taken by Hubble, and as I said, it's been artistically colored, but these pillars, these fingers here, are dark nebulae, and we see them because they're blocking light from the emission nebula, which is behind it. Go look at a picture of the Orion Nebula and you can see lanes of dust blocking parts of it. So here's a summary. What do you need to know about nebulae? First of all, we have this material called the interstellar medium. The interstellar medium is just all of the gas and dust between stars. Normally we can't see it, but in cases where we can see this material, we call it a nebula, or the plural nebulae. Nebulae are clouds of the interstellar medium that are visible, and they can be visible for several reasons. One reason is that if they are reflecting starlight from nearby bright stars, we will see this, and we call it a reflection nebula. And most reflection nebulae are blue because the brightest stars in our galaxy are usually blue. The second type of nebula is an emission nebula, and this is hot, energized gas. There has to be an energy source, so there are some different sources. Star-forming nebulae are the pinkish nebula that are stellar nurseries, where stars are being born, and they have young hot stars, a cluster of young hot stars, and that's usually what lights it up so we can see it. We can have planetary nebulae. These are the almost perfectly round emission nebulae with a bright spot at the center. These are from dying stars like what our sun will do one day, and there we're seeing it because the dying star is energizing the gas. And in the last case, we have supernova remnants. Supernova remnants are the remains of stars that have exploded in an event we call a supernova. Usually we don't see anything left behind after the supernova, at least not in optical light. The final type of nebulae that we talked about are dark nebulae, and these are made out of cold gas, so cold that we don't see it, and dust, this interstellar dust that's a bit of carbon and iron material surrounded by this layer of ice. And this dust is very good at blocking optical light, so we see the dark nebula by the fact that we don't see light coming from a certain part of space. Dark nebulae tend to be transparent in infrared and radio light, so we can go to those wavelengths and see through them. This completes Mini Lecture 1 on the interstellar medium. After you've completed the response questions, feel free to go ahead to Mini Lecture 2.